Hey everybody, today we are going to move forward with our 8.4 notes. We are on 8.4 part 2. Before we start today, we're going to talk about finding an inverse. Now, if you remember in class, I kind of had you remember inverse with a saying says go to ISS, because to find an inverse, we switch the variables and then solve for y. So again, our first step is to switch x and y. And the second part is to solve for y. However, I'm just going to add in one little step here, and that's going to be to write in exponential form and not logarithmic form. Write in exponential form. Okay, so ISS, to find the inverse, switch x and y, write in exponential form, and then solve for y. So switch exponential form, and then solve for y. So the first thing I'm going to do is to find the inverse of 1a of my blue problem here is I'm going to switch x and y. So I'm going to write this as x equals log base 5 of y plus 3. Okay, I did this portion. Now I got to write it in exponential form. And whenever I do these, I personally flip the equation. So instead of writing x equals all of this, instead of saying green equals yellow, I'm going to write it as yellow equals green. And I'll explain why in a little bit. So I'm just going to flip this around and write it as log base 5 of y plus 3 equals x. All I did was took this, moved it over here, took this, moved it over here. Okay, so why do I do that? Well, the terminology I used before was left, my number on the left, my base, to the right power, 5 to the x power, equals y, oh boy, that's an ugly y, oh boy, equals y plus 3. So the only reason I switch that is so that my terminology fits. Left to the right power equals the middle. So log base 5 of y plus 3 equals x is rewritten as 5 to the x power equals y plus 3. Now the only thing we need to do is solve for y. So how do you get y alone? Well, minus 3 minus 3. Now be careful how you write the left-hand side. It's 5 to the x power, and the minus 3 is big. It does not go in the exponent. It's down by the 5. So 5 to the x power minus 3 equals y. That would be your final answer. Okay, same thing for part B. So we've got to find the inverse of y equals the ln of 5x. Now, again, first thing, we need to switch x and y. So I'm going to write it as x equals the ln of 5y. Now again, I'm going to put this in the opposite order. Instead of green equals yellow, I'm going to write it as yellow equals green. I made those the wrong sizes though. I'm going to make it as yellow equals green. So ln of 5y equals x. Now, some of you might be thinking, what the heck is that ln? I've never seen an ln before. Remember, ln is like log natural, a natural log. The base for ln is e. That's something I would have had you chant in your head. The base of ln is e. So ln is the same as log base e of 5y equals x. Okay, so now let's write that we switch x and y. Now, let's write it in exponential power. Left to the right power equals the middle. Left, e. To the right power, x equals the term in the middle, 5y. Okay, we wrote it in exponential form. Now we got to solve for y. In other words, how do you get y by itself? 5 times y. How do you get a multiplying by 5? Divide by 5, divide by 5. You're left with y equals e to the x power. That is your inverse of that function. Okay, so that is solving inverse. So go to ISS to find the inverse. You switch and solve. The only thing we added new to that is instead of writing in logarithmic form, we're going to put it in exponential form to make our life easier. Okay, you've probably noticed I have grid paper behind, so that probably means that we are going to graph logs. Now, I understand how messy the screen is right now. I somewhat apologize for that. Again, I'm taking out a whole bunch out of the notes, so I'm finding it way easier to just write them down as opposed to typing out a whole thing and talk. So it gets a little jumbled. So I'm going to kind of color code what I'm talking about here. So the first thing I'll highlight in yellow. Graphing, the standard form of logs, is highlighted in yellow. This looks big and scary. It's not that bad. You've seen the H and K before. That's the starting point. Notice how H is on the inside, K is on the outside. I'll talk about that more in a little bit. Okay, the next portion, let's say erase all this. The next portion, it's blue, has the 1 next to it. It says logs have a vertical asymptote. So first of all, remember, an asymptote is a line that it gets really, 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 really close to but never touches. In exponential form, it looks something like this. If here was my graph, it would get really, really close to this line right here. My purple would, but it would never actually touch that. So that was a horizontal asymptote. That was for exponential functions. Now, for logarithmic functions, it's going to be very, very similar, but instead of having a horizontal asymptote, a logarithmic function has this vertical asymptote here. So that my green line in this graph, my green line will get infinitely close to that yellow line that I graphed, but it'll actually never touch it. Again, that's called an asymptote, and all logarithms, have asymptotes. Okay, next up, part 2. The starting point is HK. I kind of mentioned that, and I will talk more about that at the very end. Part 3, this is the important part. In order to graph these, again, we want to put it into exponential form. Put everything into exponential form before we graph it. It's going to be a lot easier. Okay, so here we go. It says graph y equals log base 3 of x plus 1. One thing I want to note is that there aren't parentheses around this. Notice how in my base equation, I just circled in purple, the h value has parentheses around it. There are no parentheses here. So what I need to do is, first I'm going to flip this and write it as, the first thing I'm going to do is get this 1 over to this side. So I'm going to write this as y minus 1 equals log base 3 of x. Okay, now what I need to do is, again, I talked about at the top, I'm going to write it as, instead of yellow equals green, I'm going to write it as green equals yellow. So I'm going from here to here. So I'm just going to flip the order of this. I'm going to write log base 3 of x equals y minus 1, just because I'm more used to seeing it this way. Now I need to write this in exponential form. Write it in exponential form. So I'm going to put this as left to the right power equals the middle. The base is 3. Base to the right power, 3 to the, well, it's y minus 1 equals x. Okay, now, you notice I have an xy chart. Here, I'll try to make it so this is the only thing on the screen. I have an xy chart right here. So let's start plugging in values. Well, let's plug in 1. So we're used to plugging in values for x. Let's plug in 1 for x. So 3 to the y minus 1 equals x. Equals 1. How the heck do I do that? I can't, if I get that exponent down, how the heck am I just gonna guess and plug in numbers? No, I'm not. So what that means is when we graph logarithmic functions, what we are plugging numbers into would be the y. So it's different for logarithmic functions. I'm going to plug in numbers such as -1, 0, 1, and 2 in for y. I'm not going to plug them in for x. Okay, so get out a calculator for this. You might want to use the Google calculator. There is a nice calculator. If you go to this link, gg.gg/LoganCalc, Logan like our school, calc like the first 4 letters of calculator. I kind of linked a nice calculator. I'll also put it in the comments of this note section, I guess. I like using that calculator. It's nicer than other online ones, I think. Okay. So we're going to plug in numbers for y into this function. And oh boy, did I delete what we had? Yes, that's the function we had. Okay, so I'm going to plug in my numbers for y. So let's start by plugging in -1. So we're going to plug in -1, 3, 3 to the -1 minus 1 equals x. -1 minus 1 is 3 to the -2 equals x. Okay, so now we should know that when we have a negative exponent, it flips. This would become 1 over 3 squared equals x. So 1 over 3 squared is 1 over 9. So when I plugged in -1, I got 1 over 9. Next up, let's plug in 0 for y. Let's plug in 0. So 3 to the 0 power minus 1. Well, 3 to the 0 power is 3 to the -1. I have a negative exponent. When I have a negative exponent, it flips, becomes positive. 3 to the first power is 1 over 3. So 1 over 3, 0. Here, I'll kind of make this like this. 1 over 3, so 1/3, and 0 is my next point. Okay, next up, let's plug in 1. Oh boy. So we get 3 to the 1 minus 1 power. 1 minus 1 is 0. So any number to the 0 power is 1. 1, 1. Next up, we're going to do the same thing, but we're going to plug in a 2. 2 minus 1 is 1. 3 to the first power is 3. So 3, 2. Now I just need to go through and plot these points. So I'll do this one in black. So over 1 over 9. So I barely go over at all, and I go down 1. Next up, I go just a little bit further, and it's at 0. So over 1/3, up 0. Next up, over 1, up 1. Next up, I'm going to go right 3 over 3. 1, 2, 3, up 1, 2. As you can see, my graph as I go right is going to go up and up and up and up. As I go down, it's going to get infinitely close to this yellow line. Here, I can make that a little skinnier, I think. It's going to get infinitely close to this yellow line, but it's never going to touch it. Again, that's an asymptote, and with logarithms, we have vertical asymptotes. Okay, moving along to the last problem of the day before I explain one more thing. Okay, so what I need to do here is first put this in logarithmic form. The first thing I'm going to do actually is I'm going to write it as, I'm going to switch to my pen. I'm going to write it as the ln of x minus 1 equals y. And remember, ln is the same as log base e of x minus 1 equals y. You notice on this one there are parentheses around it. So what that means is I don't break up that parenthesis until the very end. So I'm going to write this in exponential form. Left to the right power equals the middle. My base is e. Log base e to the y power equals x minus 1. Now I got to get that x by itself, so I'm going to plus 1 plus 1. I get e to the y plus 1. Again, y is in the exponent, the e and the 1 are not, equal x. E to the y power plus 1 equals x. Okay, so now what I need to do is make an xy chart. And again, I'm not plugging in values for x. I plug in values for y on these logarithmic graphs. So I'm going to plug in -1. I'm going to plug in 0. I'm going to plug in 1. And I'll plug in 2. Okay. Now, for this one, I would just use a calculator. Why? Because before we had a 3. We were plugging numbers for 3. And it was easy to do that math like in our head or just flip the negative. Now we have e. And remember, e is a number but it's 2.71, and it's going to be hard to do powers of 2.71. So I would use that calculator again, gg.gg/LoganCalc, and just use the calculator right on that screen. Okay, so the first one we get is e to the -1 power plus 1. So we're going to type in e to the x, type a -1 into the power. Now hit plus 1. We should get 1.36. I'm going to call it 1.4. So the numbers I pressed again were, I'll write it right here. I pressed on the calculator, which I am linking in the comments, is e to the x power. That is 2 below the degree thing. It's on the upper right-hand corner. It's 4 columns in, 3 rows down. I know it's kind of hard for me to say it. It's the e to the x button. Then I hit the minus sign, which is to the right of the -6. Then I hit 1. Then I hit plus. Then I hit 1. And it should be 1.4 on your screen. Okay, next up, we're going to do the same thing, but now we're going to plug in a 0. So now we have e to the 0 power plus 1. Okay, now this one we can actually do in our head because any number to the 0 power is 1 plus 1 is 2. If you plugged it into that calculator, you get the exact same answer. Okay, next up, we are going to do a 2. So we have, again, you should practice these on your own. Don't just get my numbers. Practice punching them into the calculator. We're going to get e to the first power plus 1. Now, many of you know e is equal to 2.71, but if you don't know, type in e first plus, where's plus? There's plus 1, and you should get 3.71. And again, this is the order that you type your numbers in your calculator in. The only thing that's going to change are the 2 that I'm highlighting in red. I typed in a -1 before, so now I'm typing in a 2, so instead of -1, I would just type in 2 for this next portion. So e squared plus 1, e squared plus 1, we should get about 8.4. Okay, I'm going to leave that up, so if you want to write down the buttons to press, do it. Otherwise, I'm going to erase it in about 5 seconds here. So again, if you want to write this down, pause it, whatever, write down the order to put the numbers in. I'm going to erase it just so I have more room in about 3 seconds here. Okay, so now we just got to graph our points. So x is 1.4, y is -1. Right 1.4, down 1. If I could plot it, that might help. Over 2, up 0. Over 3, 3.71, up 1. Over 8.4, which is way off our screen, up 2, so it's going to be way over there. Okay, here is our graph then. It's going to go like this. I hope you can see that our vertical asymptote is going to be this red line right here. It's going to get infinitely close to that line, but never actually touch that line. Okay, last thing. I want to talk about the difference between y equals log base 2 of x plus 1 in parentheses, so the quantity of x plus 1, versus if there is no parentheses there. So the blue one, the first one, this one, the one with the parentheses, the x plus 1 in parentheses, that would be a horizontal shift. It would move up my graph left and right, versus this one would be a vertical shift. So what's the difference between these? Well, if there are parentheses like the blue one, if I rewrote this like log base 2 of x plus 1 equals y, this is all connected. So I would do 2 to the y equals x plus 1. I would minus 1, and I get 2 to the y minus 1 equals x. Again, my y is the only thing that's in the exponent. 2 and 1 are both my bigger actual numbers. Okay, now, if it's not in parentheses like the red one, now what we need to do, first I'm going to flip it. I'm going to write it as log base 2 of x plus 1 equals y. I need to move this over before I do anything. It's not in the parentheses, so I got to get rid of it. So it is minus 1, log base 2 of x equals y minus 1. So now I would have left to the right power equals the middle. I wrote that sloppy. Let me fix this. So this is log base 2 of x equals y minus 1. Sorry about that. So now I would do left to the right power equals the middle. My base equals this, to this power equals this. So it would be 2 to the y minus 1 power equals x. I hope we can see the difference here. So if there were parentheses, the 1 is going to be on the outside at the very end. If there's no parentheses, my 1 is going to end up in the exponent. If you want to kind of write that down in your notes, that might show up on a quiz, hint, hint, hint. So you need to know the difference of solving between these, because from there, we're just going to plug in points into our x and y chart. But this is a helpful hint. So again, I'll leave it here and scroll down in about 3 seconds before.